Good morning, everyone, and welcome to Mr. Z's Problem of the Week. So I'm going to go over last week's question and provide a solution. The question was pretty tricky, so I appreciate all the students that gave it a shot. And here we go. So the question says, quadrilateral ABED is made up of a square ABCD and a right isosceles triangle BCE. So first things first, let's identify where those are. Here is my square ABCD. And here is my triangle BCE. Now the whole thing is important to know is a quadrilateral. And that's ABED. And it's important we know that that's the quadrilateral we're looking at, because if you look at the question, that is the area that we're given. We're given the area for the entire quadrilateral. So now that I look at this question and see the parts that are important, being the square and the triangle, realistically, you don't really need to know too much about that circle. The circle is not going to play a huge factor in solving this equation. At least it didn't for me. You might have had a way that you used the circle, and if you did, I'd be interested to hear about it. But I'm not really going to use the circle. So first things first, I have to determine the length of the sides of the square. Now, there's a few things that I know. I know that all the sides of this square are the same. These hashes here mean that all sides are equal. All right. So now that I know that and look at the triangle, well, now I know that these two sides of the triangle are also equal. So every side that has that double hash on it is going to be the exact same length. And that is a huge clue in solving this question. So now that I look at both of my shapes, I want to look at that triangle for a second and compare it to what I have here with the square. I know that because these two sides are exactly the same, if I flip that triangle into my square, it is going to take up half of my square. Let me just draw that in. It's important to know that that triangle is going to take up half of that square because it's going to give me a huge clue. So when I think about the overall area of ABED being 24 centimeters squared, now I know that when I use this triangle and square together, I know that the area of my square compared to the area of my triangle's area is going to be half of the square. All right, so that is a huge clue on deciding on a starting point. Okay, so because I know these are all equal, here I go with some measurements. So the first measurement I'm going to try is 3 centimeters per side. So if I use 3 centimeters per side and calculate the area for this square, I use the formula of length times width. And in this case, length times width would be 3 times 3. And that gives me an area of 9 centimeters squared for my square. Now, like I just mentioned, if you kind of got it, my triangle makes up half of that square. So half of the square, my area is 9, which I just calculated. So half of that would be 4.5 centimeters squared. And that would be for my triangle. So the total for that quadrilateral ABED would be 13.5 centimeters squared. Now, we know that that's not correct because we're looking for a total of 24 centimeters squared. So that's no good. So it's too low. So we have to go to another number, and we remember we always have to use the same number because all the sides are the same that we're using to calculate. So let's try 4 centimeters. So again, I use my length times width to find area. So 4 times 4 is going to give me an answer of 16 centimeters squared, and that is for my square. Half of that, we know that the triangle is half of that square. Half of the area of the square would be 8 centimeters squared. That's for my triangle, and if I add them both up, I get 24 centimeters squared. Hooray! We found the correct measurement. So each side is going to be 4 centimeters. So everywhere you see this double hash, those are all 4 centimeters. 4 centimeters, 4 centimeters, 4 centimeters, and 4 centimeters. Now, the question says, what is the length of BE? So I've done all this work already, and I haven't even solved the question. So I have to find the length of BE. I'm running out of colors here. So BE is this purple line here. And if we think about triangles and finding missing hypotenuse, we have to go to the Pythagorean Theorem. And the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So I know that A and B represent these two sides on my triangle, and C is always the hypotenuse. Okay, so all I'm going to do is substitute A and B with the measurements that we've arrived at, and we decided that each equivalent side is 4 centimeters. So I get 4 squared plus 4 squared equals c squared. Then I calculate my square roots. I get 16 plus 16 equals c squared. 32 equals c squared. Square root 32 equals c. And c equals, what was it, 5.66 centimeters. So after all, oh, you can't even see that. After all of that work, the answer that we have arrived at is side BE is 5.66 centimeters. Well, thanks for tuning in, everybody, and have yourself a wonderful day. Come back next week for another one of Mr. Z's Problems of the Week. Bye-bye for now.